Hello, everyone. Welcome back to my YouTube channel. So for today's discussion, I'm going to discuss post-hoc analysis or a pairwise comparison. How do we use it? When do we use it? And how to apply it in Jamovi. So the outline of my presentation, I will discuss first what is the pairwise comparison, when to use pairwise, types of pairwise, and use of pairwise in Tukey HSD in Jamovi. We have a lot of pairwise comparison, but in this video, we will focus more on Tukey HSD. When are we going to use it? So, what is a pairwise comparison? Pairwise comparison is comparing two groups at a time. So, for example, we have gender, male and female. We want to compare their test scores. We're doing a pairwise comparison because that is two groups. We're trying to compare if there is significant difference between the two. And it could also be used in three groups. For example, we have three groups. We have the third gender, we have the LGBTQ community, and then we have the male and then the female. We will use it after the ANOVA because in our other video, we discussed ANOVA. We use this one when we have three groups. So even though we have three groups, when we discuss or when we use pairwise comparison, we're trying to compare them with each other. So that's why it is called pairwise because we're trying to group them in two and compare them at a time. Then we will identify which among the three differs from one another. We will use this one comparing two. So, but even though we have a lot of groups, we can still compare them whether which group significantly differ from the other. Another one. When to use pairwise comparison? After all over significance in ANOVA or Kruskal-Wallis. So during your ANOVA test, either two-way, one-way, but in this discussion, we're just using the one-way ANOVA. So if there is a significant difference among the groups or among the treatments, we will use pairwise comparison. It is used to compare all group or selected group of pairs. So in natural science, for example, you have three treatments. Of course, this is three groups. So you will be using ANOVA. And then it found out during your ANOVA test that there is a significant difference among the three. You will then use pairwise comparison. So there is significance among the three, significant difference by using the ANOVA test. But which among the three significantly differ from one another? So are the three of them different from one another or only the two are different from the other one? So that's when we use pairwise comparison. We're trying to see whether which among the three are different from one another or maybe all of them are different from one another. So that's when we use pairwise comparison. It could also be parametric and non-parametric. So when we use parametric, we'll be dealing with parametric assumption, especially, and the most common assumption that should be met is the normality of the data. All right. Pairwise test. So we will now go to the types of pairwise. First example is the pairwise t-test. This is a test of significant difference, but we are just using the means of two groups. And it's assumed normality and it could be optional. We need to have equal variance. This is available in Jamovi, but in this video, we will not be focusing in the pairwise t-test, but we will be focusing on the Tukey HSD. So we will just trying to skim or just a few seconds and just a little discussion of the type of pairwise comparison. Then example for t-test, comparing average scores of three students groups. So if we have three student groups, we're trying to compare it using the t-test. All right. So pairwise Wilcoxon sign rank test, Wilcoxon test or what we call as Mann-Whitney. So Wilcoxon and Mann-Whitney are the same. And this one is the focus of this video. We will be using the Tukey honestly significant difference or HSD. When do we use Tukey HSD? We use this one post ANOVA test for all pairwise comparison. We controls the type 1 error. we assume equal variance and normality. So there should be equal variance and normality among the data. An example of this is a test on treatment effects, especially for experimental design. We want to test which one or which among the treatments significantly differ from one another. Okay. So the focus of this video is this pairwise comparison or the Tukey honestly significant difference or HSD. Okay, we also have the Bonfrey adjusted pairwise test, but we will not be further discuss this one because what we are discussing is the pairwise or the post-hoc analysis that is available in the Jamovi application. Then we also have the Shifty's test. I'm not sure if I pronounce it well, but that's how I remember it was discussed in our class. Shifty's test. This is very conservative and flexible, but then again, we will not further discuss this one in this video because we will be focusing in Tukey HSD. Okay, and we also have the Donnett's test and the chi-square Fisher's exact. So this is binomial. It's just a yes or no categorical outcomes. If there is a categorical outcomes, you will use chi-square Fisher's exact. Okay. This is the summary of the comparison. We have the test type. We have the t-test, the Wilcoxon, the Tukey HSD, Bonfrey, Shifty, Donnet, and chi-square. And for this discussion for this video, we will be just focusing on Tukey HSD, numeric, all group pairs, and normality. All right. Now, we will go to the use of Jamovi and how we will discuss it in the use of post-hoc analysis. Okay, so right now we're going to use Tukey HSD in testing whether there is a significant difference between the group with respect to their scores. For example, we have a problem. We have group of students. The group of students is, there are 3 groups of students. Let's just assume that, let's just name them as male, female, and then the third gender. Or we could have the anything that you can use as a group of students. Let's filter it out. Here we have 3 groups. We have the group A, group B, group C. Could also have the marital status, whether it could be a widow, single, or married, or the other one is separated. You can use that one, regardless of the number of the groups, you can use that one. But in this example, just for everybody, just for the unison of everybody, we're using the group A, B, C. And we also have, we can use also this one for treatment. Treatment 1, treatment 2, treatment 3. For treatments, it is used in experimental design. You can use this one, treatment 1, treatment 2, treatment 3, or the other groups, okay? And this is the scores or the observation. We could have the plant height, plant weight, regardless, or what is your variable of interest. But this is just for the benefit for this video. We have 3 groups. We have the group A, group B, and group C, and then the test scores. So in these test scores, we have 31. We can now run or we can use this one in Jamovi application. This data is just a sample data used for Tukey HSD. All right. Now we will open our Jamovi application. The version I am using for Jamovi is version 2.6.44. All right, so this is the Jamovi application. Here, this is a very easy statistical software to navigate. So as you can see, there is an empty space here. There is no data yet. Do not copy and paste because if you copy and paste, you still need to encode the heading. So all you need to do is to press these 3 lines and then press the open and then browse. You need to locate where is your data. So YouTube updates and we have the pairwise comparison and then we have sample data to KHSD. Okay. So again, When do we use pairwise comparison? We use this one if the ANOVA, especially when we use Tukey HSD, we use this one if the ANOVA says there is a significant difference. If there is a significant difference among the treatment, we will proceed to pairwise comparison or the post hoc analysis. So the first thing we need to do is to run the ANOVA first and test the assumption. When do we use the Tukey HSD? If there is a normality and equal variance. So here, we have post hoc analysis and we have the Games-Howell and equal variance, and we have the 2K equal variance. So you need to click here if you want to do a, but before clicking the post hoc analysis, let's find out first if there is a significant difference among the group. So the dependent variable, of course, you put it here in the score should be in the dependent variables because score is dependent with the group. Then group should be the grouping variable. And then, all right, so we have here, Welch, ANOVA, we have less than 0.001. So what is our threshold? Take note that our threshold is 0.05. So in your manuscript, you need to have, first is the statistical output. This is where you put all the output from the Jamovi. All right, all the output from the Jamovi. So here we will take note of our universal threshold, p-value, the rule of thumb. We have less than 0.05, that is significant. But for the assumptions, your p-value should be greater than 0.05 to have normality and equal variance. Variances. Okay, let's go back to our Jamovi application. Here, the Jamovi application says that the ANOVA, assume equal variances, is our p-value is less than 0.001. But before we will proceed that first, we will need to identify the assumption. We will check first if it is homogeneous. Okay, it's working. Oh, look at the p-value for homogeneity of variances. We have 0.988. So the groupings have equal variance. How about the normality test? All right, that data is normal. Now you get confused on how I identify whether it is normal or not. Run here the one-way ANOVA, and then we have the assumption checks, which are the normality tests and the homogeneity of variance, the Levens test. So all you need to do is to right-click and then press the copy, and then you need to paste it here in your statistical output. Your statistical output will be put in your appendices in your manuscript. Here we have the ANOVA and then the assumption check. Take note, for assumption check, they should be greater than 0.05. And then for the test, you need to have less than 0.05. This is the goal. So let's check first the assumption. We need to look at the p-value. P-value is indicated by the p here. So we have the p and then the p. Commonly, some of the researcher only deals with the normality. So if there is normality, they immediately use the ANOVA. So take note, if it is normal and there is equal variances, you can use parametric test. And parametric test includes the ANOVA. So let's check. Take note, the threshold here is greater than 0.05. Okay. Some of my students got confused. They are confused on how to identify whether it is greater than or less than. So you just paste it here. So if you try to look at here, the decimal, next to decimal is 4. but next here is 0. Therefore, it is greater than. So this one is correct. Therefore, it is normal. Okay? So one check for the assumption. Let's go to the homogeneity of variance. Let's check whether it is greater than 0.05. So first is you just need to look at the decimal point. The decimal point here is here, and then the next is 9, and then the next here is 0. Therefore, this is greater than. Our variance is greater than the threshold of 0.05. Therefore, this is equal variances. So since it met the assumption of our parametric test, the normality and then the homogeneity of variance, we can therefore use the ANOVA. Okay. Now we can use the ANOVA. Question, what if it is not normal? Then you will use the Kruskal-Wallis. Kruskal-Wallis is another test of significant difference. We use the median rather than the mean there. So we're done with the assumption check. We will go now to the test. So in the test, we should have less than 0.05. If less than 0.05, therefore that is significant. Okay? We paste it here so that we just identify whether it is less than or greater than. Because some of the students got confused. So we look at the decimal. This one is the decimal. The next one is 0, 0. So they're the same. So we will go to the next decimal place. We have here 0 and then 5. 5 is bigger, right? But our aim is less than. So therefore, our one-way ANOVA test here is less than 0.05. Since it is less than 0.05, that is significant. All right. So therefore, when we say significant, we could only say that there is a difference between the three of the group. So we go back to the Jamovi application. We have here significant difference. Okay, so we can use ANOVA. We will see, or we will visualize by clicking the descriptive table. It will give us the mean because ANOVA is test of the mean. So we have here group A, group B, group C. We have N, the samples for each group is 10. And we have the mean, 52.2, 51, 58.9. And the standard deviation, look at here. This might be bigger, but look at the standard deviation, it's also big. So there might be two of them are just the same. Maybe these two of them are just the same, no significant difference, or maybe this one is really have a very significant difference from the other. So what are we going to do? We will have to check, or we will now run the Tukey HSD here. We have to click the Tukey HSD or equal variances. Now it will give us the post-hook analysis. This one is the post-hook analysis of the scores. So we will have to copy this one first, copy in the statistical output. We paste it here, the mean. And then you also copy the post-hook test. All right. So copy and then paste it in the statistical output. So in statistical output, we will be using this one in our manuscript. We will be putting this one in the appendices. So how do we identify whether they are different from one another? So for the difference of one another, we need to look at the p-value that is less than 0.05. If it is not less than 0.05, therefore they are just the same. Okay? Now, how many groups do we have? We have 3 groups. And take note, when we discussed earlier what is pairwise comparison, pairwise comparison is the comparison of 2 groups. So therefore, we need to group them accordingly. We have A and A. So A and A is not here. It's empty. A and A, it's empty. So we cannot group it by itself. We cannot compare it by itself. So we will have A and B. Okay. A and B. Then we have A and C. And then we have B and C. All right. We have A and B, then A and C, then we have B and C. So C and A, already here. C and B, it's already here. B and A, it's already here, and B and C is already here. So we have the groupings now. Now, we will try to look at the matrix. We have the A and then the B. The p-value of the matrix is point. This is the p-value. Is it greater than or less than? So how do we identify? We need to look at first the decimal. We have here the decimal. Then the next one is 0. The next one is 7. So this one is bigger compared to this one. But our goal is less than. Therefore, this is not significant. The difference between A and B is not significant. If we try to look at the mean here we have the mean, 52.2, 51.0. They're almost the same, right? That's why their difference is not significant, which means A and B are just the same. Now let's go to A and C. A and C, we have A and C. Okay. We try to copy the p-value so that it's easy for you to identify. Okay, here we have to compare this one. Decimal, okay, decimal. Then we have the next one, 0. Both of them has next 0. So we will proceed to the next 5. And then here is 0. Which one is bigger? This one is bigger. 0.05 and 0.002 is lesser. Therefore, this one is significant. What does it mean? So A and C are significantly different from one another. If we try to compare the mean here, we have here the mean of A, 52.2, and then the mean of C, 58.9. So we can really see the difference, 52 and very far from 58. This is almost 59 actually. So after, we will go now to the last group. Last group is B and C. So B and C. B and C, we have the p-value here. P-value. You copy and paste it here. Just for you to easy to analyze it. But if you're a statistician, you already know whether that is significant or not. So less than 0.001, B and C. Compare this one, decimal, decimal. Next to decimal is 0. Next to decimal is 0. Then we have 5. Then we have 0. Therefore, B and C is less than with the threshold of 0.05. This one is significant. So, in this equation, we already know that C causes the significant difference. A and B are just the same. But C, it's completely different. Now, how do we put this one in our results and discussion? Let's find it out. So we are now in discussing or presenting the result. So some of you got confused because the output of Jamovi is, we have a lot of numbers, but it is different once we report or present the result of the analysis. So there should be 2 separate files. The other one is the result of the software, and then the other one is for the results and discussion. So we have here the table I made earlier, but I was not able to record it. We have 5 columns. Variable, the test score. This is the dependent variable, and then the group treatment. This is the independent variable. We have the A, B, C, and then the p-value, then the significance. Here we have the X bar, that is the sample mean, plus and minus the SD, because SD in the normal distribution is we use that one that is plus and minus from the mean. So here, how do we do this one? I will just tell you in here in the group. How do we do the X bar? So in doing the X bar, we just need to press the here and insert, and then you go to the symbol. Then we have the equation. And then the equation, you search from the structure, this one, the accent, and then you find out the one that has a line in it. You press this one and it will give you, then you click the box, then you press the X, then you will have the X. Then press the next one and then you have the insert and then symbol, then you will have the, this one is plus and minus. That's why we have it here, plus and minus, and then you just type the SD. Okay, what does it mean when we the SD? SD stands for standard deviation. Some of the researcher they want to put it here. SD means standard deviation. But if you already know, you don't need the legend that they standard deviation. Here we have the p-value. P-value comes from your ANOVA. We have here the less than 0.001, and that is highly significant because it is less than 0.01. That's why it's highly significant. Then we have the X bar. X bar stands for the mean. That's why we have here the mean, 52, and then the SD is 3.62. It should be separated by the X plus. So just copy and then paste it here. Sorry, paste it here. Yeah. And we have 51 and 3.78. You paste the X plus and minus. And then you have the 58 and then 4.07 here. Is it here? All right. So this one, you identify again whether A and B are the same or not. You need to put the A. It says here, same letters show no significant difference. So the small one or the A is the lesser value. Then we have the B, small a, this should be small a. And then B, the bigger value. So if we look at the mean here, 52, this one 51, but in our post hoc analysis, we have the, it is not significant. So therefore, we will put A here, also A here. And then for the C, because C is different from A and B, we will put B. All right. So we can see here that group A and group B have the same letter, which is A, which means they are the same. But A and B is different from C. So the reason why the ANOVA results is 0.001 is because of group C. All right, group C. Maybe this type of students are really smarter than A and B if we assume that section A, section B, and section C. And here, section C has the highest mean test score, which means that section C has the higher group, higher group or test score. So we will change the design or the table layout, table design. Some of the design don't want to have a border. Only at the top, we have 1.1 at the bottom, 1.5 at the top. And then we have it here. Oh, sorry. We have here 1 point. In this area, we have, from the column heading, we have 1 point. So that's the presentation. And then afterwards, need to discuss. All right, let's discuss it. Okay, we are now discussing it. We have here, we have the identification, whether the testing the difference is the test use is ANOVA or Kruskal-Wallis. You will have to superscript it. And then since we use the ANOVA, our superscript here is 1. All right. Then you have the table name. You have comparison of test scores among fitments, and then you have the discussion. Here, the discussion, the test scores, this one, the variable of groups here, A, B, C, or treatment, A, B, C, were compared. And the results show a highly significant difference, this one, with a p-value of less than 0.001. Group A had an average score of 52.2 with a standard deviation of 3.62, while Group B had 51 here with a standard deviation of 3.78. Then Group C had a much higher average score of 58.9. So, based on the letter A, Group A and B are not significantly different from each other because they share the same letter, A here. Group C, marked with a different letter, B, is significantly different from the other two. This means that Group C performed better, and the difference is unlikely due to the chance. So it's not just a chance. Group C is really smart. So that is pairwise comparison and how to run Tukey HSD in Jamovi and how to discuss it. So thank you for watching my YouTube channel, and I hope you have learned a lot from here, and I'll see you again for my next video. Bye.